this is a quantity that's, if you're going to keep talking about over and over again, this is going to be the heart of electricity. So we might as well understand this very clearly. So I'm going to put a inverted comma to tell you a very simple definition for an electric field. An electric field is an indicator, so it is an indicator of the force on a +1 coulomb at any point. That's it. Okay, how much force a +1 coulomb experiences at any point. So let's directly take an example, and you will see how easy it is to understand what an electric field is. So let me call this point as point A, and that is some random point in space. Okay, so this is a point in space. It is vacuum, point in vacuum. So there is no matter whatsoever. Even though there is no stuff there, we can still define there's something that's called as the electric field, and say if I told you that the electric field was this way, and let's say I told you that the electric field at that point was, for example, 200, whatever the SI units are, we're going to define the SI units. What it means is that if I kept a coulomb at that point, so if I kept +1 coulomb at that point, then that charge would experience a force. It would experience a force in that direction, and that force would be 200 newtons. That's what it means. It's the force that a coulomb experiences at any point. That's all. But guess what? If you know what's the force on a coulomb, you can calculate the force on any other charge. So let's say I kept, instead of a coulomb, I get +2 coulomb. How much would be the force? Well, common sense tells us that if 1 coulomb experiences a force of 200 newtons, then 2 coulomb should experience a force which is the double of that. So the force on this guy would be 400 newtons. So you see, electric field is, and although it's an indicator of the force on a coulomb, it's a useful quantity to calculate force on any charge kept at that point. What if I kept 3 coulombs? It would be 3 times 200. Alright, but what if I kept a minus charge? So I don't have to keep positive charge all the time. I can also keep a negative charge. So what if I keep a -3 coulomb? -3 is going to be a little bigger. Let's say I keep -0.5 coulomb. Well, if a positive charge experiences a force in one direction, well, obviously the negative charge is going to experience a force in the opposite direction. So now it just means that the force is going to be in the opposite direction, but again, the amount of force, the magnitude, is given by this number over here. It's 200 for a coulomb, so for half a coulomb, it would be half of 200. That would be 100. So let's redraw that point A over here, and I'm going to draw that same point. Okay, and the electric field is given, and that electric field is given to be 200. So I'm going to rewrite that. And now my question is, what if I keep a general charge? I keep a q coulombs of charge at that point, charge q. What's the force that's going to experience? Well, if it's a positive charge, it's going to experience a force in this direction, and I'm going to assume it's a positive charge. Then that force is going to be, well, notice that since this is the force on a coulomb, force on q coulombs would be just q times 200. Q times 200. In general, we can say force on any charge kept at A is just going to be Q times the electric field at A. And that's what an electric field is. It's an indicator, that's what's given here, an indicator of force acting on a unit charge. So that's all there is to it when it comes to an electric field. So the definition, mathematical definition of electric field at any point would be the force acting on a charge, any charge kept at that point, charge Q, divided by that charge. So look at the units, it's going to be newtons per coulomb, so we can just call that as newtons per coulomb. And that's what an electric field is. It's a vector quantity, by the way, because it's an indicator of force, and force itself is a vector quantity. Ta-da, there you have it. That's an electric field. Let's discuss more about this in the next video, so stay tuned.